Tang, short for hyperbolic tangent, is a popular activation function in deep learning. It squashes any input value into the range of -1 to +1. Tan also has an S shape, but unlike sigmoid, it is zero-centered. Output goes from -1 to +1, passing through 0 at x equals 0. Tang is smooth, differentiable, monotonic, and zero-centered. These properties make training more stable compared to sigmoid. In neural networks, Tang takes the weighted sum and outputs values between -1 and 1, making it easier for the next layer to learn both positive and negative signals. Just like sigmoid, Tang suffers from vanishing gradients. When input is large positive or negative, the derivative becomes almost zero.
Advantages. Zero-centered output helps gradient flow better, strong negative and positive values, and was widely used in recurrent networks.
Disadvantages. Still has vanishing gradient issue in deep networks. Computationally expensive due to exponentials. And outputs are not strictly positive.
Tan is better than sigmoid because it's zero-centered, but ReLU is faster and avoids vanishing gradients in hidden layers.